Hello, everyone. My name is Apurva. I work as a senior data architect within Mphasis team. And today we are going to look at end-to-end life cycle of operationalizing AI ML based home loan recommendation model for customers with existing loan portfolios through proprietary Mphasis MLOps framework. And we have selected this use case as it aligns with strategic goals of First Republic Bank, and it focuses on household debt refinance and first-time homeowner programs, as these are two major growth levers to attract next generation of clients for First Republic Bank. We have platform approach using MLOps principle to manage end-to-end AI ML solution lifecycle. And I will walk team through the different capabilities of ML Ops platform to enable frequent experimentation, streamline development, deployment, monitoring and updates of model using MLOps framework. I will also talk about capabilities of early data and model drift detection mechanism, thereby establishing best practices for model performance management. In the end, I will wrap it up by discussing business benefit of how Mphasis MLOps platform enables faster time to production for model, thereby enabling faster business insights generation. Model governance by maintaining different versions and audit capabilities to monitor change between different versions through Model Hub, automation to build accurate models quickly, and continuous solution management to analyze the data, newer data set that we get and provide business insight to the end user. Now, when you think of a machine learning projects, they are very complex in nature, as there are many moving pieces involved as highlighted in this slide, starting from configuration, data collection, data verification, resource management, analysis tool, management tools, process management tools, infrastructure, and monitoring overall. So machine learning projects are not as mature as software engineering. So we don't have a one-stop solution for operationalizing machine learning pipeline end-to-end. And that's where MLOps framework comes in as a breakthrough solution to give end-to-end capability for your machine learning initiatives. Now, when you think about machine learning framework, part of the reason why they are different is because you need different kind of skill set. You need to have a different mindset when you're looking at the creating process of a model and how you're going to deploy that model. For testing those models, there has to be a different mindset because you're looking at the business challenges that you're trying to solve and how you're going to predict the business outcome based on the data that you have collected from different downstream systems. Base ML Ops framework has, at the core of it, it has two components. One is a process component and the other one is technology component. As I mentioned earlier, ML Ops framework, the process component is more about how do you establish the skill that are required for creating this kind of machine learning models. Because if you think of it, any machine learning model in the case, you want to have reproducibility for this model. You need to have some kind of audit mechanism. You need to have some kind of explainability to understand what is happening within the model, and it should not be a black box model. And the idea is one should have visibility of model across different use cases so that we can take this model and deploy, do some customization to it and deploy it to different use cases to make sure that we have validated the model using different data set and across different edge cases to make sure that your model is performing as expected. And obviously we need to have monitoring process in place to check what are the model data drift and infrastructure health checks to make sure your model is running optimally in your environment. Now, as you can see from the screen, right, when I'm talking about ML assessment, not every project would be an ML project. So we have to go and look at the ROI for the project, whether is this, for this project, is machine learning the right approach or not? Can we get a return of our investment by a standard rule-based system, or do we need to have different kind of prediction that would enable us to take some business decision based on the data that we have collected? When it comes to collaboration and pipeline, from the collaboration standpoint, we need to have an approach where multiple data scientists can work on this model, and they can iteratively go through this model and improve the performance given the business use case. And at the same time, we have to track this model tracking should be incorporated to understand what is happening and what kind of changes have happened between different versions of the model. At the core of this complete machine learning pipeline, data is the center of it. So we need to start looking into the data and do a proper preparation of this data, including take proper step to pre-process the data, profile the data, and in the end, select what are the key important features available out of this data that can be used to define business outcome. And there comes the part of the model, where you have to deep dive and understand what features are more relevant for this specific model. Now, once you have the data set available to you, you need to take this data and train your model. And then you have to take this trained model and validate and test this model using different data set, testing data set as well as validation data set. And this has to go through an iterative process between your model development and testing, because at first run, you might not get the accurate model or the kind of accuracy that you are looking for. So it is an iterative model, and you have to optimize on the baseline model over time, depending upon additional data set that you get. Now, when you think of traditional software engineering world, right, you have a standard DevOps pipeline that you would initiate, and deployment process would trigger your DevOps pipeline. But machine learning is kind of different in a sense, because it is not as mature as software engineering, and we don't have out-of-box tool available to do this complete end-to-end operationalization of ML models in the production environment. So with Mphasis MLOps framework, we are bringing the DevOps mindset to machine learning pipeline, and we are integrating with GitHub and Git Actions to automate the complete deployment process. And then in the end, once the deployment is done, we monitor the model in production environment to test what kind of drifts are happening on the model. And if we need to do some kind of retesting or validation of the data. So in the end, with this framework, we are providing end-to-end pipeline operationalization framework, which right now in industry, we are facing a lot of challenges because we don't have a complete end-to-end solution. In terms of benefit, there are three major benefits that we get from this approach. First one is speed to market. It improves speed to market significantly because now we are using different kind of toolchain, and we are bringing automation in the complete pipeline process. Second, traditionally machine learning model tend to be a black box approach, but with our framework approach, we are enabling governance with IT audit trails for this machine learning models, which we are incorporating with the automated checks and monitoring to make sure that we have proper visibility in terms of what is happening behind the scene in an ML model. We also want to avoid any kind of model performance drift, and that's where we are continuously monitoring, and we are proactively testing our biases so that every model that we have developed have proper type of explainability behind the scene. Now, this is the overall end-to-end architecture for MLOps framework. Now, as you can see, the core aspect, the fundamental layer here is data preparation layer. So we look into data imputation if there are any kind of missing data. We want to make sure that we have a data extraction module. So if we have complex data sources, we are able to extract the data. We are able to clean the data and as well as wrangle the data, because most of the time data are not the source data that we get, they are not cleaned properly, and we cannot use them directly and apply it to our data science model. And the important aspect after we go through the data cleaning process and data preparation process is feature selection. And while we do the demo, you will get more visibility in terms of what are the steps involved and how the flow is when doing the feature engineering. Because you can have 100 different features in your data set, but not all features would have same weight when you are thinking about outcome or prediction for the business insight that you're trying to achieve. So that's where your feature engineering plays a very critical role, because you have to go in and look at the top 3 or top 4 features which can explain your model and which can give you prediction for your given use case. Now, once the data is prepared, it gets split into 3 separate data sets. You have test data set, training data set, and validation data set. Training data set is used primarily for training your model. Validation data set is used to check accuracies for your model throughout different stages of training. And during this training process, if at all there are new features coming in, or if validation data detected that model is not performing as expected, the training phase needs to be optimized, and model now gets trained on a new set of additional parameters. Once the validation accuracy is as expected, then we move to testing the model on the sample data set. Once we have passed this phase, this is where we take our model into production. And this can be between taking your model and putting it to on-premise server, or taking your model and establishing a pipeline for end-to-end process. Now, when you see from the deployment standpoint, you need to know what are the benchmarks of the model, how your model is integrated with the larger overall system, how your model is being monitored. Are there any kind of audit mechanism in place or not? If are you doing real-time monitoring of your model? So let's say if your model is failing, or if it is not, if the accuracy level falls below a threshold, do you have an automated way to trigger restart of the model and reintegrate with the data source to rerun the model? And do you have proper explainability for your model? These are all key features that you have to address before going into your deployment phase. And when I show the demo, I will clearly explain what it means in terms of how MLOps can address all these different challenges. Now, as I said, data preparation is the crux of this entire experiment, as it requires significant effort to transform the data into suitable format as needed for machine learning. We have also integrated it in the overall ML pipeline, because you don't want to end up in a situation where you have a different team that is preparing your data, and you have a different source target team which is getting this data and then trying to build model on this data. We want an end-to-end system wherein we can integrate data into the system, we can do pre-processing of the data, and then at the same time we can model, we can create a model, and there again we can use a no-code AutoML approach for creating your model. Or if we have enough skill set from the data science perspective, we can build this model in-house. But going with the no-code approach, it expedites the time to market for creating this model. Now, in terms of different phases, right? When I say ML ops, there is a development part of it, and then there is a machine learning part of it. And here it gives you what are the different stages within the development phase, and what are the different stages within the operational stage. So if you look at development, you have your data preparation, then you have model development. As I discussed, you can go with a no-code approach, or you can go with a you can develop your model in-house. And then there is a significant amount of time that we need to spend on testing the model, to test for correctness of the model, to test for performance of the model and efficiency, and at the same time, what is the explainability level of this model? Because if you, tomorrow, if you have a different use case, if you can take this model, are you able to understand how this model was built in the first place? And can you draw some parallels which can be applied to a new use case? Moving over to your operation side. Now, on the operation side, you have two different approaches. You have your deployment, you have your production. So for deployment, you integrate with your GitHub, you have your end-to-end pipeline, and you have a collaborative platform wherein different data scientists within the larger organization, they can come and they can work together on the accuracy of the model and try to improve the model. and then they can call GitHub action, and they can deploy this model into production. And on the product, once it is in production, you want to make sure that you have your features around governance, monitoring, continuous tracking of model behavior and model performance. These parameters are important because for a financial firm, there are a lot of compliance and regulatory requirement from regulatory agencies. So we want to make sure that while we develop this product, it shouldn't be a black box, and we should be able to provide visibility in terms of how our ML model is built, and what kind of predictions and insights it is generating for different authorities to comply with the regulation requirements. Now, as you see here, there are a bunch of different tools here. I will not go in detail of which, but if there are any interest, we can always have offline conversation around that. So PaceML, right? As I said, it gives you an end-to-end framework. You're talking about assessment, starting what are the guidelines for the project, and then you go on and talk about different collaboration frameworks and how you would approach this from a collaboration standpoint, how you would leverage your Git actions to do some kind of code checking, unit testing. How can you create your containerization approach on your model? So the idea is to bring your learning from a DevOps environment into a machine learning project and create an end-to-end MLOps framework. I'll not talk more in detail about each one of this because I have covered the explanation of it in the earlier slides. But on a high level, this is the end-to-end 9-yard feature capability that MLOps provide out of box. With that, I'll take you to the demo, and then we can come back and we can discuss about the benefit part. I'll quickly stop my share to reshare my screen for the demo screen. Let me know if you can see my screen.
Yeah, we can see it.
Thank you. So now, as I discussed previously, the major components of this ML ops framework, you have your data engineering, that is your starting point. Then you go about data pre-processing, data profiling, data augmentation, featuring. Then you have development. Here, you go with the out-of-box AutoML approach, which gives you ability to pre-select models, and depending upon your different selection criteria, you can look at either R-square or RMSE or accuracy level and pick and choose depending upon your use case. And you can collaborate with your team. As I mentioned, you can integrate with the GitHub and try to work with your team and create different kind of models if you want to develop models in-house. Now, the most important part here is about experiments. For any data science or ML initiative, you want to innovate quickly. And this is where the importance of experiment come into the equation. You have a certain set of data set, but you want to be able to run your experiments quickly and have multiple different models working on the same data to see what kind of insights you are getting and what is the correlation between those insights, and how does that map to correlation between different versions of your model and different models that you have taken into account. And then finally, we have development and we have monitoring, and I'll go in deep of each one of this section. I just wanted to give you a quick overview so that you know what is coming. Now, when you see here, we have this data pre-processing. So I'll quickly load a data file, and then I'll show you what kind of things I'm working on. So if you see here, I have loaded bank advisor data file, and now I'm trying to do some data pre-processing on gender column type. Now, if you see here, we have this gender depicted as F and M, but I'll try to apply ordinal encoding because there are some use cases where instead of having F and M, you want 0 and 1. So It will take a 30 seconds, but the idea here is this is one type of pre-processing that you are doing. You can also apply non-zero variance, apply cardinality reduction, and different kind of techniques based on your data. So as you can see here, after imputation, you have this 0 and 1 instead of F and M. And here, if you want to go and check what kind of changes has happened, you can come here, you can see that, hey, before imputation, you had F and M, and after imputation, the format has changed to 0 and 1. And as I said, you can do a bunch of different pre-processing steps on depending upon the nature of your data and the kind of use case you're trying to solve. Now, platform also provides you ability to look at the profile of the data element. Now, why this is important? Because you want to have statistical understanding of different data elements that you are loading into your ML model. By giving this visibility, as a user, you would know that, hey, out of my 100 columns, maybe customer ID column is not very significant. I mean, its p-value is not less than 0.5, right? So the idea is you want to identify very significant data elements in your data and then use them to leverage those significant data elements in your model to generate insights. And this correlates with the feature selection. Now, here you have to go in manually and you can see, okay, you have some level of highlight saying that, okay, this few data columns are significant and few data columns are not significant. If you see here, other loan tag, this data is not significant because we don't have enough information that we can derive by analyzing this column. So then you can ignore this column while you're trying to run your data model, your machine learning model. Now this is about your feature selection. And again, I'll quickly run this and I'll show you how this module works. Now here what we are trying to do, we are trying to remove multi-collinearity from your data columns. So there are instances where in your data you might have 3 different columns, but they all signify a similar output. So statistically, if you take one column into account, the other 2 columns become insignificant because the insights or prediction that a model can make out of this data, the insight that can be generated from 1 column and as opposed to insight that can be generated from 3 columns, there is a very small delta. So instead of considering all 3 columns and taking that into account, you can collapse your data and you can just take 1 column instead of having 3 columns. So you see here, I mean, before imputation, you had a lot of data columns available here. You were looking at your balance, you were looking at min balance, different kind of information captured. But after imputation, you're seeing all these columns are converted to 0 and 1 because these are not very significant columns that would affect the output of the model. So now instead of focusing on all 100 columns, you can identify top 30 or maybe top 50 columns which has good significance on the output of business column. And the benefit of this is you have less data to work with. So from the operational side of it, you have less challenges when you're trying to maintain this model. And also going forward, when you want to update this model with a newer data set, you're trying to limit your variables. So your output accuracy would be more better compared to taking all 100 columns into consideration for running your model. Now we'll talk about AutoML. So as I mentioned earlier, the benefit of using AutoML is instead of a developer creating their model on their own, we can leverage out of box model that AutoML provides. And AutoML provides different kind of accuracy level and metrics, and it gives you different algorithms. When you are trying to do classification or regression, it has a portfolio of models which AutoML would run, and it would give you different kind of metrics to see how each of those models are doing and what is the performance metrics for each one of that. So if you see here, AutoML is giving us leaderboard. Now, what do I mean by leaderboard? So it has ran through almost 15 to 20 different algorithms, and it has provided accuracy level, recall, and precision. All these are metrics on which a particular model can be measured. So these are different performance criteria for your specific model. You can build this model on your own, but that is going to take a lot of time. Now, with this approach, you know that, okay, for my given use case, decision classifier is a better model to use because it has accuracy of 0.88 and it has recall of 83 and precision of 0.87. Similarly, if you have a different criteria, right? Let's say if you're looking at kappa or you're looking at F1 value, then you can filter your model on those parameters. So the idea is, instead of spending a lot of time building the model, you focus more on the business case and what are the business output that you would want to drive. And that's where your AutoML can improve your speed to market with this different models. Now for collaboration, when you click on collaborate, you have this different models, right? So you come here and this is shared between your different teams of data scientists. So they can come and they can set up different kind of jobs. They can initialize different containers. They can run different kind of actions. Essentially, what you're trying to do is you're trying to create a platform. Think of it from a traditional software engineering standpoint, right? A developer does a code check-in. You have a different developer who would look at your check-ins and who would say that, okay, these comments are good, I approve it, and let's move it to deployment. This is a similar kind of approach where you have a collaborative nature, but now we are talking about a data science model and how you would set up your job, how you would initialize different kind of controllers, what kind of Git actions are you're taking behind the scene. And those are the kind of insights that you would get with your GitHub integration. Now, the most important aspect of Pace ML Ops framework is your ability to run experiments, quick experiments to see what is happening behind the scene and what is the variation between experiment that I ran a few minutes ago and the experiment that I'm running now. So if I go here, and if I click at this experiment, you see it is using extreme gradient boosting. So that is one of the algorithm within the data science models. And it gives you clear visibility in terms of, okay, what was my base estimator best score, what kind of booster I'm using, all these metrics it would give you. Similarly, it also gives you details about accuracy of your model, F1 score, kappa score. So if you remember, this is same output that we had seen from AutoML, but now we are able to run these multiple experiments and then we can compare, okay, what are the metrics that you're trying to analyze your model on? And is this version better than the previous version? And you have all this information, run ID information, runtime, what kind of source you're getting. So the idea is to get visibility. Now, another best aspect is, now you have run this model, right? You have deployed this model. You want to play around with this model because this was auto-created by an AutoML system. But I'm a data scientist, I like to get my hands dirty, but I don't want to spend time building model from ground up. Instead of that, I want to look at the data, look at the model that AutoML has created and do a deep dive on that model and understand what kind of things they are doing and try to customize that model based on my needs and based on output accuracy metrics for my specific business use case. So you can always go in, you can download your model from here and you can work on that model and try to customize that model. So this gives you ability to not only build your model from scratch or use an auto-created model from AutoML, but gives you ability to go in and customize the auto-created model based on your requirement. So it also gives you benefits of both worlds. You don't have to start from zero, but at the same time, you have like almost 70 to 80% model built, and you can go in and you can do performance tuning on the model to optimize for your specific need.
Yeah, Purva, quick check on the time. We have 5 more minutes to.
Sure. So I'll quickly go through deployment experiments.
Sure. Thank you.
So here, behind the scene, we are using MLflow and enCore as our deployment engine. So you can select either one of this engine. You can select the experiment ID, and then you would have your list of pre-populated experiments that you have run, and you can select any one of it, and you can define your endpoint, and you can try to deploy it. Now, the other important aspect is monitoring. You want to make sure that your model that you have created, you have ability to look at the model and see the performance of the model. You want to check the monitoring on your experimentation. This gives you visibility in terms of when you ran that experiment, what was the source, in what stage that experiment is, what is the run ID, and like how well that experiment did. You also have different kind of training parameters and validation metrics to look at the accuracy of your experiment and how your model is actually performing. And if you want to compare, you can take 3 different experiments and see that which one has performed better to give me insights given my business use case. Deployment monitoring gives you visibility in terms of, are there any kind of errors in the deployment process? If yes, what kind of errors? Was there any kind of delay in getting the prediction? What are the latency for the endpoint? So from the infrastructure side, it gives you a lot of visibility on where exactly your model is and how much time it is taking to get deployed. And then another aspect is to look at your different data, and you want to make sure you have visibility into monitoring your data for different experiment. Now, same data element can perform differently within different models, but having this visibility, you can go back and you can look at the data and see that, okay, why this specific data element performed better in experiment 3 and why it didn't perform better in experiment 1. So the idea is to give you as much visibility as possible so that it's not a black box system, and you as a data scientist or a technical person can deep dive and do some kind of customization to get further insights into it. And these are the health checks for your production environment to see where exactly your experiments are, whether it is staging, production, or archived. And then finally, you have this CPU and network metrics. These are more for the infra guy to go and check whether they have all the information that they are looking for or not. So I'll quickly go back to my slides. So essentially, this is the end of the demo. But what I want, if there is few things that I want to take away from this demo, is the speed and time to market. Nowadays, a lot of time is spent in developing the model grounds up, but we have tools available and we have capabilities. So instead of building models from grounds up, maybe we can have a baseline model which satisfies maybe 50 to 60% of our need, and then remaining 30 to 40% we can build on top of it and we can customize it. The other part is around data preparation, because 80% of the time is spent around preparing the data. So you want to make sure you have tool, and it should not be a fragmented system. You should have end-to-end tool, and that's what we have built for our customers to give them visibility all the way from preparing the data to developing the model and then monitoring. So this covers whole 9 yards of the system. And then obviously one has to think more about automation and try to minimize the manual intervention while creating this machine learning models and deploying it into production environment. So those are a few of the key points that I wanted the audience to take away. With that, if there are any questions, I would love to answer any one of those. And if not, I'll hand it back to Ravi.
Yeah, thanks, Apurva. And team, please feel free to ask any questions you may have. Or you can send it out to me as a follow-up. We will get those questions answered. So hope you guys found this demo useful. I will wait for a minute before we close this room for any of the questions you guys may have.
Ravi, there is a question from Madhu. I'm not sure
Yeah.
if it's answered and he's satisfied, or does he need a follow-up? In the chat window?
Yeah. So Madhu, are you satisfied with the answer, or you want to follow up for this one?
Yeah, I am. I got a response back from Rekha offline, so I'm good with it for now.
Thank you. Any questions from anyone?
No questions. Call out. Really well done, and this is very relevant for us. So we'll possibly have some more deep dives to figure out how we can start leveraging. And as I have mentioned, more of these kind of tools and lessons learned and best practices we can share better for us.
Yeah, sure, John.
So thank you very much. Really appreciate this.
Thank you. All right. All right. If there are no more questions, thank you very much for all of you joining our demo today. And we will share the recording version as well. And if you have any further questions or follow-up needed, please feel free to reach us out. And we have a demo for the second demo, which is going to start in next 5 minutes. So you can take a break and join back. We will start the next 5 minutes. Anupam, you had something to say?
I was just saying that there are other testing booths as well. So if you go to the main lobby area, there are other, the data, the integration, testing, etc. So please feel free to kind of go everywhere and just explore. Thank you.
Yeah, thank you. Thanks, everyone. See you again after 5 minutes. Thank you.